Hello everybody, I've picked some questions from the work that I signed on Monday, April 27th for the intro to the exponent law stuff. You would have seen some of this last year in grade 11, but we're going to try to post some videos on showing you guys how I would go through the examples. There's lots of videos you can find online, but they're not me. So we picked 4 questions here. We'll go through them. We'll try to keep the video short in the future as well as today, just so you guys don't have to spend your data on this kind of stuff. So first question here, we have 4x to the exponent 3 times 2x to the exponent 3. So this dot here, you'll see in your work, it means multiply. So this here actually has 2 steps involved. First off, you have a 4 times a 2, and then you have x to the exponent 3 times x to the exponent 3. The 4 times 2, you can go ahead and solve that. That gives you 8. And then you have x to the exponent 3 times x to the exponent 3. Now you have some exponent laws you guys are working on. And the way to simplify that is to simply combine the 2 and add the exponents. So you end up with x to the exponent 6. And you'll notice all we're doing here is simplifying. You're not going to have an answer like 8 or 12 or 72 or minus 4. Whenever you have a variable like x or y or z, you can only simplify. So 8x to the exponent 6 is as far as you can simplify that expression to. Next one, you have 6 to the exponent 5 divided by 6 to the exponent 3. What you're going to use here is you're going to use what's called the quotient rule. You have the same base, 6 and a 6, and you have exponent 5 and exponent 3, so you can simply subtract them, and that's your shortcut. That is simplified. You can't go any further. If you wanted to evaluate it, you could. You could say, okay, that's actually 6 times 6, and you can put the answer there, but for now, we're just simplifying. So, first 2 done. Next 2. Okay, so I picked number 11 and number 13 to give you guys some variety as well. If you guys have any other questions that you want me to go over, just simply shout me out on EDSBY, or reach out saying, hey, how do you know number 8, number 12, whatever. I will gladly give you guys walkthrough pictures of how to do it, or I can do other things as well. Just let me know. Reach out. Okay, so here I have 6 divided by 2, and then I have x to the exponent 7 divided by x to the exponent 4. You could look at it as the whole thing as 6x to the exponent 7 divided by 2x to the exponent 4. Doesn't really matter. You're dividing, so you should know that you're using the quotient rule. Right? Up here you're multiplying, so use the product rule. So we're going to use the quotient rule. I have 6 divided by 2. I can do that part. Then I have this, x to the exponent 7 divided by x to the exponent 4. So what the rule says is that they have a common base of 8x. So you can subtract the exponents, which means that it's a simplified version of that question. And the last example I picked here is you have a combination. You have this being to the exponent 2, which is called the power of a power from your sheet that I attached on EDSBY. And then you also have another power of a power here. But even though C and D don't have exponents, if you have any letter or number on its own, the exponent's always going to be 1. So you still do have a power of a power here. That is exponent 5, that is exponent 5. And then after that, you have this answer times that answer. So you actually then have a 2-step question here. You have power of a power, and you also have product rule. So when you see a question like this, try to think of using your BEDMAS rules, right? Oh, should I do the multiplication first? Well, don't do the multiplication first because you have some exponents you got to figure out first, right? Multiplication is way over here. So don't do 2 times 1 and C times C and figure out the exponents first. So here I have 2 to the exponent 2, C to the exponent 2, and 4 to the exponent 2. 2 to the exponent 2, I'm just going to leave it like 2 to the exponent 2. Your power of a power says you multiply your exponents, so that's going to be 1 times 2, which is going to give me 2. And here, your d to the exponent 4 has an exponent of 2, so you simply multiply. So you expanded the first step, and that's kind of what you have left. Over here, just for saving steps, I'm just going to do it all in one. So 5 times 1, 5 times 1, you have c to the 5, d to the 5. Now already that looks a lot more cleaner, neater, right? You've got rid of the double exponents. Now all you have left to do is to multiply. You have 2 squared c squared d to the exponent 8 times c to the exponent 5 d to the exponent 5. Right? Now if you really want to get specific here, there is always a 1. How many c5 d5s are there? Well, there's 1. So what you can do here is multiply the numbers, and then multiply the c's, and multiply the d's. Right? So we've done stuff like that before. The reason why you can't multiply an x times a y or a 12 times a q, they're not the same things. You line up the same things, the coefficients, the 2 and the 1, the c and the c, basically collecting like terms kind of, or working with like terms. So 2 squared times 1 is just 2 squared, because anything times 1 is itself. Then you have c to the exponent 2 times c to the exponent 5. I'm going to rewrite it out just to make it the last example, so we'll write out a little more steps. Then you have d to the exponent 8 times d to the exponent 5. Again, this right here, you're going to be using the product rule, which means you have to add the exponents. Right? So c to the 2 times c to the 5 gives you c to the 7. And then d to the 8 and d to the 5, add those together, and that's going to give you an answer of d to the exponent 13. And that's it. You can't go any further. So I can do more examples for you guys down the road. This is the first one. Provide me with some feedback. Let me know if it helps. And again, if you have individual questions you want to ask me, message me on EDSBY, and I will gladly send pictures of how to do the steps as detailed as kind of this stuff here. Okay, see you guys soon.